Hello again, my name is Diana Chan and I am a tutor at the Natural Social Science Lab at MDC Kendall campus. In this video I'm going to work out a problem to find an isotope's atomic weight. Previously we were solving for the average atomic weight. This is the number on the periodic table. In this video we'll solve for the isotope's atomic weight, either isotope 1 or isotope 2 given the other variables. So let's just dive right into example 3. Silver with an atomic weight of 107.87 has two naturally occurring isotopes. The isotopic weight of one isotope is known to be 106.91 and occurs naturally at 51.85%. Is the other isotope heavier or lighter than silver 106? Looking at this problem initially, it may seem like there isn't enough information. Hey, we only have the information for one of the isotopes. We can solve this question either intuitively or solve it by simple math. First, we'll use math to solve this problem, and next we'll look at the answer and see if it makes sense with what we know. So first things first, this problem will need the help of this equation also from Module 5, where fraction 1 plus fraction 2 equals 1. So 51.85 can also be converted to 0.5185. or 51.85 over 100. These are all the same things. And remember that I like to use it in decimal form just because it makes the computing on the calculator a little bit easier. So just plugging these values in to this formula, the 0.5185, we can solve for F2. And now we can subtract 0.5185 from both sides. And we get 0.4815. Now, remember, this can also be 48.15% or 48.15 over 100. Okay, so F2 equals, I'm just going to put it in decimal form, for F2 equals 0.4815. Because we know that there's only two naturally occurring isotopes, because the fraction of isotope 1 is the percentage is 51.85%. We know that the percentage of isotope 2 has to be 48.15% because there are only two isotopes. We can now plug in this information into our formula from Module 5, and I'm just going to write down the givens from before. We know that F1 equals 0.5185, F2 equals 0.4815, average atomic weight is 107.87, and the atomic weight of isotope 1 is 106.91. So let me just plug that into this equation. So just plugging and chugging, I get this equation. And remember that these need to be in either decimal or fraction form. Do not put it in as the percentage whole number like this. Simplifying the math with multiplication, and now I'm going to subtract 55.43 from both sides. We see that 0.4815 times atomic weight 2 is equal to 52.44. Now we can just divide both sides by 0.4815 to solve for AW2. So here we see that the average atomic weight for isotope 2 is 108.91. Now to look at this, we have to see, does this make sense? And yes, it does, because for our average to be 107.87 and one of our isotopes to be 106.91, the second isotope must be greater than the average, or 107.87. And let me show you in this little diagram. Again, our value needs to be greater than the average for 107.87 to be our average if the other isotope is 106.91. Okay, so that is the third example we've gone over. In the next example, we'll go through how to work out a problem if there are more than two isotopes.